Hello everyone, this is Lutao from Baidu Incorporation. Today I am here to present PP-HumanSeg, connectivity-aware portrait segmentation with a large-scale teleconferencing video dataset. I will introduce it from the following aspects. Portrait segmentation has brought great success in various entertainment applications, such as virtual background, beautifying filters, character special effects. Among these applications, video conferencing has become a major scenario where participants could automatically replace their private backgrounds with virtual scenes. The outbreak of coronavirus has further accelerated the prevalence of video conferencing as working from home has been desired. There are three challenges. First, the current meeting scenes become much more diverse in surroundings and lighting conditions, as live video are recorded from each participant's home. Participants may show various postures and actions, even wear face masks. In addition, participants may access to the teleconferencing using a web page running on a browser or a chat app running on a mobile phone. Thus, there frequently needs to ensure real-time performance in resource-limited computing platforms. All these practical issues have brought greater challenges and opportunities to portrait segmentation field. There are examples of our dataset and existing datasets. In existing datasets, FVS contains only 4 green screen videos. Due to the composition effect, the labels are not smooth enough. And MADA contains a lot of similar images and irrelevant information of the interface of the software. For example, virtual buttons and small windows. So we release a large-scale video portrait segmentation dataset that contains 291 videos from 23 conference scenes with 14,000 fan-labeled frames provided. Our dataset has 4 advantages. It contains various scenes, various actions of the participants, interference of passing-by, and illumination change. We provide high-quality labels in both pixel level and video level. For pixel level labeling, there are 2 ambiguous instances. In video conferencing, the purpose of portrait segmentation is highlighting participant-related parts rather than the surroundings. The handheld items highly related to the activities of participants. However, distant passerby or people with bags are not participants, which should be ignored. Therefore, handheld items are labeled. Distant passerby or people with bags are not labeled. We also annotated our videos based on the objects. Each video clip has multi-class attributes. For example, the scene ID. The video level annotation can be used to video description and multitask learning, which also provides a good start point to human activity analysis study. We also collected pure background images in different scenes. Then we use a simple video composition strategy to augment the dataset. More labeled images is composed of the extracted portrait parts and the pure background. We generate 1 million images eventually. Due to the high quality annotation, the edges of the composition data are smooth and look natural. Also, portrait segmentation is a subtype of semantic segmentation. It has distinct characteristics comparing with other object segmentation. The person can be regarded as a non-rigid object, so that the postures and appearance are varying. In addition, Generic semantic segmentation is pixel-level classification which ignores the completeness of the Poisson instance. Thus, we propose self-supervised connectivity-aware learning, named SCL. It is a new learning framework that takes care of a completeness of Poisson instance, subject to varying human action and postures. Specifically, in addition to using traditional semantic labels as a supervision, SCL extracts the connected components from semantic labels and uses them as the supervision signal fill a semantic connectivity loss. We define a new concept, namely semantic connectivity, to represent the segmentation results and ground truth. Specifically, we use the connected components to represent the completeness of Poisson segmentation. In Poisson segmentation, we take the region of a Poisson instance as a connected component. So, how to define semantic connectivity? We first find the connected components of prediction P and the ground truth J. We use a connected component labeling algorithm to calculate the connected components. We then transverse all connected components to find all pairs that intersect with each other. In this figure, there are three pairs, G2 and P2, G3 and P5, G4 and P4, and three isolated components, P1 and P3 and G1. The connectivity for Gi is denoted as Ci, which is calculated with equation 1 and 2. If Gi is an isolated component, Ci equals to 0. Finally, we define the semantic connectivity of the entire image as equation 3. SCL frameworks use a novel loss function based on the proposed semantic connectivity, which minimizes the inconsistency of connectivity between prediction and ground truth. We denote semantic connectivity aware loss as 1 minus the SC of P and G. Note that there is a special case that no pair exists between P and G, and connectivity is becoming to be 0. It could happen in the beginning of training due to the random initialization of parameters. However, 0 connectivity would lead to 0 gradients, and the weights cannot be updated. For such a special case, we design a non-trivial loss function to call start the process to ensure the differentiability of the loss function. Finally, SCL incorporates the SC loss as a regularity to complement with the segmentation losses, for example, cross-entropy loss, to optimize the model. We propose an ultra-lightweight segmentation network to work with SCL, namely ConnectNet. It adopts an encoder and decoder structure inspired by ShovelNet. The encoder follows an inverted bottleneck blocks design with channel shuffle operation to extract features efficiently. To reduce the computation load while maintaining high resolutions, ConnectNet compresses the number of stages and channels, while every stage is stacked by multiple blocks. Moreover, ConnectNet incorporates depthwise separable convolution to improve the decoding efficiency in the decoder. The encoder would lower the resolution of feature map and lose the spatial details. Spatial information is critical in segmentation tasks. Therefore, the proposed network connects the encoder and decoder through a skip connection to integrate the underlying texture features. It is more conducive to generate fine masks. At the same time, the skip connection directly reuses the features extracted by the encoder without additional computation costs. Experiments. In order to show SC loss is parameter insensitive and robust, We conduct 5 experiments with different weight coefficients. As shown in Table 1, the MLU on almost all ratios are improved. We evaluate the effectiveness of our assay loss on lightweight networks. As shown in Table 2, the MLU metric improves in all networks. Through enhancing the connectivity of the connected components, the models obtain the better segmentation performance. Comparison with other sort losses, including low-wise loss and ML loss. These losses focus on different aspects of semantic segmentation, like class imbalance and structure information. Assay loss has the best score in MLU and pixel accuracy. The evaluation result shows the assay loss has sorter performance. Effectiveness of connected net. We compare it with other lightweight sorter models. Compared with HRNet, our model has greater performance and 40% faster. Compared with FastSN and BaseNet, our model is 1.2 and 8.5% higher in MLU, respectively. The experiments show that our model outperforms BaseNet and FastSN to a greater extent, but only have less than 10% of their parameters. This is crucial in mobile and web applications, considering that the storage requirement is rather strict. We visualize the predictions of different networks on test images. Our model has better completeness than other models. It is less prone to make dispersed predictions, like here. Our solution has been applied to Baidu video conference. It is a web video conference software. Let's look at its effect. Users can replace or blur the background to protect their privacy. Let's conclude. In this work, we introduce an open source solution for practical portrait segmentation named PP-HumanSeg. First, to facilitate the progress in portrait segmentation in video conferencing, we constructed a large-scale video portrait dataset. Second, to improve the completeness of segmentation results, we propose a self-supervised connectivity-aware learning framework, incorporating a novel semantic connectivity loss. Third, we propose an ultra-lightweight model. The proposed solution achieves the best trade-off between LU and inference time. Fourth, extensive evaluation on our dataset demonstrates the superiority of SL and ConnectNet. Finally, the source code and dataset is available at our GitHub repo. Thanks for listening. And please start if it helps you.